Good evening, YouTubers. Welcome back to episode 20 of Shrigleytube TV. I can't believe we're 20 weeks in. That's 20 bags of popcorn you'll have got through every Sunday night watching me witter on about Hillman Imp engines. Anyway, if you're new to the channel, welcome. If you're returning, thanks for returning. I hope you're enjoying what you see. I've got mainly engineering in this week's video. There's no dyno time because I didn't finish the 1040. I tried, but it was a bit of a push, so I thought we'll take our time, we'll get it next week. Customer's cool, no big rush, let's just get the job done right. So I'm not going to list everything that's in this week's video. It's on the heading, and I hope you enjoy it, and come back to see me again next Sunday. Okay, hope you enjoy the rest of the evening. I'll speak to you next week. Cheers for now. Good morning, YouTubers. Welcome to this week's episode of Shrigleytube TV. I didn't do any filming yesterday. It was Monday yesterday. I was busy building the bottom end for this 1040, and today I'm on the head. Now, I've just put new guides in the head, and I thought we could do some valve seat cutting together, and on how I haven't got the best system, but it's a system that works adequately, we should say. So, bit of background, the valve guide and the valve seat really important because the valve obviously goes up and down in this bronze guide here, and its function is to seal. So when the valve lands on that seat, there's a 45-degree angle on that seat there, on that valve. If we just zoom in on it, you can see it. It's a new valve, and then we have a matching seat with the same angle, and the idea is that it stops any air from getting past. So all the combustion pressures are used to push the piston down rather than leaking past the valve. So really important. And I've just fitted new guides in here. These are Colsibro guides. This head's just having a bit of a refurb. It's actually an Andy Chesman head from back in the day, so it's quite a nice head, but we're going to do a little bit of fettling. There's not a great deal of improvement we can do on it, but we'll do a little bit. Now, I am going to take it from 1.32 to 1.4 inlet valves, which is going to involve the seat to be cut bigger. The new guides are in, these Colsibro guides, and they need finish honing. They're still tight, but I've left them tight because when we machine the seat, this is the pilot. I want the pilot to be as snug as possible in the guide so that it has as much control when we're using the cutting tool, which will all become apparent in a minute. So the basics: the valve seals on the seat with the 45-degree angle that you can see there, and we sometimes lap them as well with a paste just to get a witness mark. You know, you've all heard of valve lapping, so we get a witness mark so we can see where the contact area is, and then we know that the valve is going to seal properly. Now, problems that occur with the Hillman tend to be mainly the original cast iron guides. They wear, and the primary function really of the guide, apart from to keep the valve obviously going up and down in a nice manner, is to take the heat from the valve and the stem into the guide, and then into the head and into the cooling jacket, because the valve gets very hot, especially the exhaust valve. So what we often see with the Hillmans is that it's like a vicious circle of going wrong, where the guide wears. When the guide wears, the valve doesn't seat, it bounces a little bit as it lands, because it's obviously not central, because it's got wear in the guide, and then that wears the seat, and then the valve starts to recess, which makes the valve lose its gap, so it has a valve clearance with a shim. So when that shim closes up and it gets tight, what we have is the valve can only lose its heat through two methods. One of them is the time it spends when it's pulled hard against the seat by the spring, obviously when the cam's at the top. So when the valve is shut, the head of the valve can lose its heat through the valve seat contact, and also probably the primary heat loss is through the actual stem. So the stem is nice and snug in the guide, but if the guide's worn, it's not contacting the stem properly, so it can't lose its heat. You might remember we did a bit on the CVH last week with the 1600 CVH. Now, the Ford Escort RS Turbo with the CVH engine was the first mass production engine, I believe, to use a sodium filled exhaust valve, and they were really expensive. So if you had a cam belt failure, you often found that people had put the standard exhaust valves in rather than the sodium filled ones. And the idea of the sodium was they were hollow in the head, and then the stem was hollow, and the sodium was really good at taking it. Obviously it all got excited inside here where it's going up and down, and it would take the heat from the head of the valve and take it into the stem, so the heat could be dissipated through the guide and into the head, into the cooling jacket. So a bit of a background there as to why it's really important that the guide's in good condition. So obviously the bit I just never actually came to because I got sidetracked there was to say, when the guide's worn and the valve can't lose its heat, it's then that we see the valve overheat and the valve starts to burn out, and then you get a burnt out exhaust valve, mainly because that's the hottest valve. Obviously the inlet one's got the nice petrol and air going past it, so it keeps a bit cooler, whereas the exhaust one's got the red hot exhaust gases going past it. So yeah, we see a lot of burnt exhaust valves on the Hillmans, but if they're maintained properly and the valve clearance is maintained and the guide's in good condition, they're absolutely no problem. Like, these heads don't even need seats put in them to run unleaded because they already have a valve seat, being an aluminium head. So if you use these stainless steel one-piece valves, just all the problems of unleaded fuel goes away. There's just no issues with them. Right, so moving on. The way this tool works is, this is the pilot. So we drop this into the guide to the bottom like that, and then we have a spring, and that is just so that the tool is always pushing that way, because you'll see in a minute when we get to the miller that the way we do it is we lean on the tool and push it against that spring so it rubs. And then we have this device. It's got like a ball end with a drive, so it's like a big CV joint, so it doesn't transmit any load from the, it just allows it to center on the pilot. So that goes on there like that. This goes down here, and then you can see if I push it hard enough, just zoom in there, it comes down. You see it just cutting there, but obviously we use the machine to do this. So how do we set it? Well, I'll go through setting it first. Just zoom out. I might need to put the camera on the stand for this bit. I'll try. So this is the setting tool. So all we do is we get the valve that we're going to use, we put it in there, and I've actually already set this. This nut's undoable, this little nut, and what we do is not like that. We set that pointer right to the outside diameter of the seat, can you see? So when that's set, which it is now, the next thing we do is we put the guide in the tool head. Try and do it one-handed, and then we pop that in there like so, and then this whole part here is like a cross slide. It's got a grub screw there and some pinch bolts, and I can move that in or out so that I can set the cutting tip to cut exactly where I want it. So you can just about make out there we've got 3 angles. We've got like a lead angle, an after angle, and the main angle. I'll just pop that down and try and zoom in. I'll try and use my pointer so you can actually see it. So it's falling away from me. What's this I picked up here? Right, so there's the main seat, that area there. So I need to set that pointer to the outside of there, and that will be the tool set, and then I can go and in fact what I'll do is I'll stop talking and I'll put the camera and do it together. Right, hopefully the camera's focused correctly, and what you'll be able to see is the pointer which we set on the valve, and then I've got this screwdriver in here, and you can see it by turning the handle I effectively move its position relative to the guide. So I'm going to set that so the pointer is just on the not quite, it's just not focused quite right, but you get the gist anyway. So I'll set that so that it's just on the outside edge of where they want the seat to finish, and then we'll go over to the milling machine and we'll start. Okay, we're on the miller now, and I was going to just say before we go any further, that's I've done the first seat. I've just cut that on my own because as you probably got the gist from now, I can't multitask at all. So I've set my height using the this little device here. So as I bring the head down, that goes up and down like that on this handle, and then it gets to there and it won't go any further. So that's my height set now. So in theory, if the head's the same thickness all the way across, which it should be, all the seats will be the same height. So when we come to build it, the shims will all be a nice uniform, or within a few far of each other. So this was the ball-ended thing I was talking about before that goes in here. This is the drive, so it transmits the drive through the pegs, but obviously allows it to move, so it'll find its own sensor, because that's what it's all about. We want the seat to be cut relative to the guide hole where the valve runs, because that's the whole point of it. So that's going to go in there, that's going to go in there, that comes down onto here like that. The head's tipping, which is bad news because something's not right. That's what's not right. Oh, I've got my new microphone cable tangled up. Right, I'm just going to pause it while I do something. Okay, so I've just put a stop there. So, because I leave the head free so it centers on the guide. So it can't come past there. So I'm going to start it going. Incidentally, I've spoken to Bob at B&J and I've asked him if I can go down and video him with his Newen machine cutting a valve seat, because that's a proper machine. This is the old school way. It's quite a lot of load, quite a lot of contact area on the tool, so we do get a bit of chatter even though I'm going very, very slow. So what we have to do is we always have to lap them afterwards and make sure they're correct. But when you see Bob's machine do it, which is a very expensive machine, you'll be really impressed with that. That does work well. Right, I'll zoom in, we'll start going and we'll see how she cuts. Just see the top angle starting now. Right, I'm hard against the stop now, so it won't go any further. So hopefully it's got it all the way around. Have a quick look. I think I did hear it cutting everywhere, so you can see we've got the top angles cut now. So what I'll do is I'll put a valve in and we'll have a look at it and see how the seats, how concentric it is to the guide. Okay, I've just spun the head round. I've done the first three. I'm on the last one and I thought, oh, it's a much better viewing angle for the camera from here. So I'll do this last one with us together again now. Hopefully you can see what's going on a bit better. You can see the seats now appeared, the 45 where the valve sits. What I'm going to do is I'm going to hold the pressure on against the stop and let what I call the tool rub out. What I'm listening for is for it to be cutting uniformly, so we've got no high spots anywhere. I think it's just catching somewhere, but yeah. We'll see how that looks. Just lapped the first one in, number 4, the last one we did. So you can still see, I'll just zoom in a bit. You can see the other seats are still shiny. Now where I've lapped it with the paste, you can see it's got like a grey ring. It's really easy to lap in. We just use the this like rubber stick here on the end of the valve with some grinding paste and lap it in. So what I'm looking for, obviously the valve here it's a brand new valve, so if the valve was bent, we'd have an interruption in the grey ring, because obviously it wouldn't have contacted on one side. But we can see there, as expected, the new valve is straight. So looking all the way around the seat, I can see it got a nice grey ring. And if I drop the valve in, just bring it out a little bit. The thing I like to hear is a nice, and as a last check, we do the daylight test, because the light never lies. So we shine that all around here in a circle like that, and have a look, and I can see it's seating perfectly. So I'd expect that to, you know, have really good leak off test if we did a cylinder leakage test on this engine. Now, of course, I'm not going to get massively involved with it, but the big issue with an imped is, because there's so little left of it when you've machined it all, the head does distort a bit when you tighten it down. So the valve seat doesn't always stay as concentric as it is right this very, very second, where it's all free. But anyway, that's another subject. Right, wonderful. Well, I'll get on with lapping these, and then we'll set up and do the exhaust side, but I won't put you through that. Okay, chaps, we're just on with building the head for this 1040, and I put the valves in. This is when we cut the seats on a minute ago on the video. So really pleased with that. All the seats are a nice height, all nicely uniform to start with, and because we've gone to a bigger valve, the seat now sits at full height. Now the problem we've got now, which is what I was going to do a bit of machine work to get round with you guys, was this is the race cam that I'm going to fit in it. This is a reprofiled cam with 400th hour lift, and this is an old school cam with 360th hour lift. Now this cam is reprofiled from one of these Wilder cams, so you might think, well, how have they got more lift from a cam that's only got 360th hour lift? And what they do is they basically regrind it off the base circle. So if we zoom in, I'll try and get a good picture. This base circle here, if I were to measure either side of the circle of the base circle on the cam, is 23.8 millimeters, and this one is down at 21. You can see how shallow it is there. So that's where the materials come from. Now, as a spin-off of doing this, it's really good for the Hillman, because one of the problems with the Hillman is when it's on full lift, the cam follower pops out of the bottom of the carrier so much that sometimes they use a tip. But because we are starting higher up on a smaller base circle, and obviously the top of the lobe has been machined, the cam follower now doesn't stick out as far on full lift. So that's a little win that we do get. But because of the fact the valve is nice and low, because it's high in the chamber but it's low on this side, and we're on a small base circle, I can't get this to work with my range of shims. I need like 150 thou shim. So what I need to do is I need to take 40 thou 1mm off this face, so that it brings the whole lot closer, so I'm back in the range to use my the shims that I've got available to me. But what I thought I'd do is, rather than just machine the whole thing, which is what I've done in the past, I thought if I set it up with a milling cutter, I could follow this line and hopefully leave the intrusion there, or the material to support the bucket. So that's what we're going to do. We're going to take this over to the miller now and see if we can machine it together. Okay, so I've got the carrier bolted upside down to the table of the machine now, and we use this milling cutter. And you can just, if I zoom in, you'll see what I've done is, you'll see the shadow of where the cam carrier has been sat on the cylinder head and where it's not. So we don't need to machine all this portion because it's in free space, but we do need to machine this part. So I've just done a rough line with an etcher all the way along, so I can see where I've got to machine to get the carrier to sit at the right height. So I'm going to start by, what I'll do is I'll do the straight bits. Obviously, to do this angle here, I've got to move both handles on the machine at the same time. This one that controls it going backwards and forwards, and this one that goes that way and that way. But I'm not going to do that because I'll make a mess of it. It'll end up all jiggedy. So what I'll do is I'll spin the carrier so that we just use one axis to move it, and it machines it in a straight line. So I might set this up on the tripods and put it in slow-mo. Okay, I'm off the miller now, so you can probably see what I was trying to get at before. Where the cam carrier comes into contact with the head, I have machine clearance, and then the rest of the place I've left it high so that it's got the support for the followers. So I'm quite pleased with that. It's not turned out absolutely amazingly like CNC style, but it drops on beautifully, and I'm sure that we'll have the valves in the correct, the clearances in the correct range now, so we can get on with building it. Good morning, YouTubers. Something a little bit different. I often get asked to remove broken studs and bolts from modern cars because I'm on a trading estate full of garages, and the guy next door's come in a bit of a pickle and said the lads snapped this bolt, one of the lads in the workshop, my pal Slippers. So he's asked me if I'll drill it out basically. Now it's a bit of a pig to get to. It's M12 from what I've measured, and I thought we'd go through it together, so if you end up doing a job in your garage, hopefully on something nice and old, not something modern and rubbish like this, you know, throwaway cars that we drive around nowadays, I'll be able to help you to drill it out yourself. Now it's really easy to drill out this bolt. It looks like a catastrophe, but if you start on the right foot, you'll be fine. Follow these steps and you won't go wrong. It's all about keeping it central. You can't afford to wander off. If you look, we're lucky here because we've got like a pilot hole that we can use to guide us through. So I'm going to start by grinding this excess material off with the slitting disc, and then what we're going to do is, I've got my drills ready. We're going to do a 5, an 8 and a 10. What we're going to do is we're going to go in a little bit with the 5, a little bit with the 8, a little bit with the 10. Obviously it's M12 by 1.5 the thread, so the maximum size I want to go to is 10.5. If I keep it central, we'll be able to chase the bits of old thread out with the tap at the end, but we'll see what happens. I'm not hopeful at this stage. It's quite a long way to go. As you can see, it's all the way through there. So the important thing is sharp drills. If you've not got a drill, if you can't sharpen drills yourself, you need to buy a drill sharpener. And the most important thing when you're dealing with something that's quite hard is speed. We don't want to go too fast. We just use enough speed from the drill to cut. As soon as we see it stop cutting and start to rub or making a squeaking noise, you stop, sharpen the drill and start again, because once it work hardens from rubbing, that's when we get in real trouble then, because you can't get through it basically. So I'll grind this off and then we'll start drilling together. Right, we'll start by grinding off this remaining bit of material so we haven't got to drill through it. So I've got the slitting disc, got my safety googles on, got the grinder that doesn't work. Right, hopefully that means now that we can start to drill it. Now the worst thing you can do if you're thinking of trying to weld a nut to it, what's happened is, because it's aluminium, the bolt's reacted over time because I had no lubrication on it when it's gone in, and it's fused itself, so you're never going to get it out. Even with heat, it still picks up and wrecks the thread, so your best chance is just to drill it. The problem is if you try and weld it, when it cools down it hardens. It makes it even harder to drill out. So we just grind it off, so we know that should be fairly soft. I should be able to get on that now and center it and start going through, and I'll explain as I go how I'm doing it. The most important thing about this job, there's two things that are really important. The first thing is you don't rush it, and the second thing is you don't rush it, because you rush it, you'll cock it, and then you'll be full of regret because it'll be wandering off into the aluminium. And once that drill hits the alley, because it's softer than the iron or the steel, it just wanders and there's nothing you can do about it. Okay. Right, what I've done is I've just dimpled the very end of the bolt, and hopefully if we look down here we'll see it's as concentric and as central as possible. This is the most important stage. If you get this bit wrong, then the whole job's knackered. Now, the way I do it, if I just, obviously I've got this going in here, so I've got this much variation that I can use to chase the center part of the drill into the correct starting point. So obviously if I saw it going too much over here, I'd angle the drill up to make it go down that way. And we'll just do a little bit of drilling together. I'm just going to go slow because it's cutting. Not very well. Might have to sharpen the drill. I think it's blunted off a little bit. Right, it's going to be a really hard one to do this. The bolt is really hard. So I'm going to go real slow. And hopefully it'll start cutting. Could be a long process, this. Okay, we've had a good start there. It's still bang on central with the 5mm drill, and we're in about, I'd say, 8mm. So what I'm going to do now is I'm going to change to the next size up drill, which is 8mm. And because I've already got a hole, a pilot, this should hopefully follow the center of that, and it should chew for it real quick because it's not going blind into a hole. It's got a hole to follow, so it's much easier for the drill to push through. So I'm not using the full speed of the drill because I don't need to. I'm just using enough speed for it to cut. So you can see it's going through it like toffee. Now we've got to the bottom, and it feels like it's gone a bit softer as well. So we may have, I don't know why it'd be harder at first. It could have been that they'd attempted to get it out with a bit of heat. Anyway, we'll go to the big drill now. This is a 10.5. I think actually I chose a 10, so we've got, if it's M12 by 1.5 pitch, we take the pitch from the M12, the 12mm, that gives us a tapping size of 10.5. I'm drilling it 10, so that'll hopefully, if we get it bang on central, that'll leave 0.25 of a millimetre aside. That's 1/10 of a side for us to just wind the old thread out with the tap. That's if it all works correctly, which is highly unlikely. So this one should go in like toffee as well now. So all the time I'm looking to see where the cone is and how close to the outside. I can see it wants to go a little bit that way. Right, that's perfect. I can see we've got a steel bit all the way on the outside, which will be the 0.25 millimetre we've got left, plus the obviously the shape of the thread. So we've got a skin of 0.25, and then the not the tooth. What's the best? The thread, the pitch, basically. Anyway, I'll go on slow-mo now, and then I'll go back in with the 8mm, and we'll start rattling through this. Right, I've just paused on the time lapse there because I wanted to just explain something. I've got a clearance hole here now. I've just gone in with the 10mm. So this is the 8mm, and what I'm doing is all the time I'm modifying the angle at which I'm attacking the broken part of the bolt, because you can't just plough through, it will wander. So if you judge the gap around the outside by looking all the time, I can see that the gap is a bit close on the top. So if I lift the drill up and push that way, obviously I'm going in like that, exaggerated, but I can keep it central, and that is critical, because if you don't adjust your angle when you're ploughing through, you will wander off and you will run into trouble. As soon as you hit that alley, you're in trouble. You've got to keep it in the steel. Right, I've got the mole grips on, and I can tell that it's breaking in a funny way, which means I didn't quite get it right. But hopefully we'll be able to salvage it and get the remainder of the steel bolt out. So, oh, there you go, it's broken. Right, so looking at that, we were off by about a mil or something. I can deal with that, I can get that out. I'll carry on chasing it now, and then we'll collapse it. Right, I've just not videoed that because I had a visitor with me, but I've had to snot a bit of a long extension on this tap because obviously with it having this here, I ran out of depth. So all I've done is I've gone in and cleared out the old thread. I've gone like half a turn, then back, half a turn, break. You have to break the threads, so you go in, turn back, etc. So done that, and it's cleaned up okay, to be fair. I thought it might have more corrosion in it, but it was actually alright. So I haven't, if you just, don't know if you can see in the end of the thread there. So I haven't got a bolt long enough because I don't have M12 stuff. I've got a little M12 here which I can screw in, and I can tell it feels fine. That, so we'll call that job jobbed, and we'll go and get rid of it, and then tell him don't give me any more stuff that distracts me from what I should be doing. Morning YouTubers, it's Saturday morning, bit fresh, -1, and we've got a visit from a Clan Crusader. This is Alistair. Alistair, just can you tell us a little bit about this fantastic little car you've got here?
Yeah, so this is a 1972 Clan Crusader that we got out of a barn about 5 years ago, and it's had everything done from the ground upwards. And I've just driven it down from Cumbria, came down to Preston last night and then down through the traffic this morning. So I think we've been confusing a few people on the M60 first thing.
Wow, it's certainly quirky, and they're really popular these days, these, aren't they? You know.
Yeah, they're getting really popular, and they're good motorsport cars. They're comfortable ride, and yeah, it's come down very smoothly down the motorway all day today.
It's a slippy shape. I bet it's quite economical once it's going.
Once you're up and cruising, it's absolutely fine. I mean, it's a little bit blows around on the motorway a little bit, but not too bad. And they were very, very low drag coefficient. I think when the team designed it, they basically got Myra's book of drag coefficients and put the whole lot into the design. And it's a first wedge, I think, very early wedge.
Wow! It's a shame they couldn't have put a bit of that into the Hillman, because I think that's more aerodynamic backwards than forwards. But we're going to just have a look at your engine. We're going to pull the cam cover off and just check the torques of the head bolts, because it was a new engine, probably, is it 2-3 years ago?
Yeah.
And we'll have a look at the tappet clearances as well, and then we will give it a little fire up. It does sound very sweet. I do like the exhaust on it. So yeah, brilliant. Well, thanks for letting us look at your car, Alistair, and if you've got any popcorn, sit yourself down Sunday night at 7. You can watch yourself.
Excellent. Love it.
Cheers. Right, we've finished pulling the head down on the Clan Crusader engine now, the 913 Sport, and thought we'd have a little peep inside here, because it's quite a pleasant place to be, isn't it?
Oh yeah, it's not too bad. A bit fresh in the weather, but it's good.
Yeah, 6 o'clock dash, and a digital radio as well. Yeah, very nice. Yeah. Can you fire it up for us, please, young man?
Yeah, we'll give it a look. Yeah.
Just give it a little blip, just so we can. Lovely. And dials. Whacking. Right, safe journey back. Thanks very much, Alistair.
Excellent. Cheers.
Cheers.